there. All right, so we can go ahead and get started. I don't have a lot planned per se. I would like to go a little bit more into some of the SQL injection stuff I've been working on, answer any questions that people might have about the videos that have come out so far or upcoming videos, dive deeper into some of the SQL injection topics that we've covered or will cover. Also just talk about where the channel is going, what the channel has been, not what it's been doing because it hasn't been doing anything, but just kind of in general talk about what's going on and what I'd like to do and talk to you about what you'd like to happen and just kind of get back into this thing. I think for live streaming, I know before the channel was almost entirely live streaming and I just don't have the time for that. I didn't have the time for that before, obviously, which is why I stopped doing it. So I think monthly live streams is probably where I'm going to target, and those will be more, kind of Q&A and we can do some hacking challenges here and there and stuff, but it won't be the focus of the channel. The focus of the channel is going to continue to be pre-recorded videos. I'm gonna hopefully get better at editing at some point soon. But yeah, that's kind of what I've got going on right now. How's everybody doing? We've got a few people in chat. Let's see. Make sure the containers are up and running. Okay, so if we want to do some SQL injection stuff, we can. I'll flip over what the focus is. Obviously, we've got the other side. We've got the window up here, but we'll flip to a different scene if we want to actually do some demos and get into stuff. Is the mic set up on the other side? Hold on one sec. All right, now the mic's set up on the other scene as well. Like I said, it's been a few minutes since I've done this. My old OBS configurations didn't even still exist. I had to reinstall OBS. I have an entirely new computer than when I used to stream, so a little bit of growing pains. It was previously set up for recording, so things are a little bit different, obviously. But welcome. It's good to see everybody back. It's good to be back. Thanks for I really miss doing this. I didn't stop streaming because I didn't like it. I just got overwhelmed and burnt out, and I needed to recover and I needed to heal. My new job is still demanding, but it's I'm able to balance a lot easier in my new job, which is nice. So wanted to get back into this. This was one of my goals for a while now, is to get back into creating videos and creating content. And so I am really happy to be back. I'm happy that the SQL videos are doing pretty well. I'm not a YouTube star or anything, nor is that the point of the channel. But people seem to be liking it and reacting well. So hope if people are learning, that's what I want. That's what I want to happen. So let's see here. So just to kick things off, feel free to ask questions or whatever whenever you want, and I'll address them as I see them. But just to kind of get things moving and not sit here awkwardly, we'll jump into some SQL injection stuff. Maybe give you a preview of the video I'm working on right now. Obviously, I haven't put out a video this week. It's going to have to come later today. I did get a little bit busy this week. I was actually taking a class on some Azure stuff, and the class was East Coast time zones, and I'm West Coast. So waking up super early and then being in a class all day, I just did not have any energy at night to work on the videos. But I can give a little preview here, kind of go into some of the topics that'll be in that video. Previous video, last week's video was intro to SQL injection, and it kind of laid out the basics of how to look for SQL injection and how to execute some normal SQL injection and whatnot. But what I find in the wild, whether it's what is happening here? Why? Oh, let me just fix this real quick. What is happening? Why is... I don't understand why my cam's not on. It's not that important. You're not here to see me, but... oh, there it is. Just takes a minute, I guess. I don't know. Yeah, so what I actually see in the wild, either in bug bounties or on pen tests or whatever, is we end up having to do what I call, or what is known as, Boolean inference. And some people call it blind Boolean inference, and I don't really like that term, because blind SQL injection is more for when you get zero feedback, and what we're doing with Boolean inference is making the most of minimal feedback. And some examples of that is, like if you try and log in someplace and you get, username is invalid, instead of getting username or pass invalid, you can actually create an account with a username, and do your SQL injection. And if it tells you that the password is invalid, then you know that the username is valid. And if you get the username is invalid, then you know the username is invalid. And you can chain that with Boolean logic in SQL, and start teasing out information about the database in the back end. Another really good example of this is, we sometimes encounter devs that are trying to do the right thing, and they put some sort of filtering in place, but they don't do the proper prepared statements, which is the thing you actually should do to fix SQL injection. And next week's video is going to be on mitigating SQL injection, so I'll talk more about prepared statements in that video. Excuse me. But so you end up getting certain things filtered. So for instance, I've seen like union filtered, which is super weird. Trying to stop people from doing something like, union select, username, password from users. So you type that in, and if you followed along in last week's video, like that would have worked, right? If we go to, basic.php is the main site. So if you do that here, you'll actually get the table spitting out the information and whatnot. But over on this no union, the code on the back end is actually filtering anything that has union in it. So we can't use a union. So what we need to end up doing is figuring out a way to dump data without using a union, or by inferring information from a true-false response. And what that looks like is we end up using something called substring, a SQL statement called substring, or function. I'm going to use the words function and statement and clause probably incorrectly a lot. I'm not a DBA, and DBAs can get really pedantic about that kind of stuff. It doesn't really matter what like a substring is probably a function, I guess, but whatever. So the way substring works is this: if we If we open up, let's open up our SQL. So we'll do a docker exec ti SQLi site db1. Oop. And bash. And this is one of the reasons that wait, what? Oh, this is one of the reasons that I think it's really important, and why I started out the series with like how to install MySQL or how to get MySQL configured and running on your box, because it's so much easier to test things locally and make sure things should work in the database before we move on to attacking web applications in the wild. I've found that I've wasted, hours or sometimes days on an exploit against a website, and then I'll back up and I'll install SQL or I'll install whatever, and just try and do the thing I'm trying to do on the back end to see if the payload even works. Like forget about trying to exploit the vulnerability, but the actual thing I'm trying to do on the back end, does that even work? And sometimes I find that it doesn't. And I've actually stumbled upon the exploit, hours or days before, and it just didn't work. Not because my exploit didn't work, but because the payload didn't work. So it's very handy to have something on the back end that you can kind of test against. And once you start getting better at understanding what the web code or what the Linux configurations or whatever on the back end should look like or commonly look like, you can even start prototyping the potential vulnerability on your local machine and test and iterate there, before you start launching things against the target. And that's really helpful for both like detection-based penetration tests, so almost more red team, where you're trying not to get caught, and they're not only just testing their technical controls but also their detection and monitoring controls. So being able to prototype locally, where you'll be very noisy and trying a bunch of stuff at once, and then once you get your exploit figured out, sending that specifically is helpful as well. So let's get into the database. Let's see. So do this because I'm taking OCP next month, and the MS SQL is a nightmare. Yeah. I mean, so how long ago was it? I took OSCP in, I want to say like 2014, maybe early 2015. So it's been a minute since I've done it, but I did not understand what they were trying to say very well in the web app portion, and specifically the MySQL or just the SQL stuff in general. I think that a lot of people, I think the way that web app pen testing is taught in a lot of places is insufficient, because they teach you, and I mean, I know it's an entry level class, but I think that OSCP is especially guilty of this, is that they teach attacks. And what I find when I'm interviewing people and when I'm hiring and whatnot is I'll get a lot of people who know my friend and I call them the incantation, the spell. Like they know the words for the spell to make something happen, but they don't know why that works, or how to modify that, or how to find it. They just have this like list of spells that they can cast, and they just kind of like cast all of them, and if one works, then great. But the only way to get better, the only way to know what to do when your spell doesn't work, is to understand the theory behind it. And I think that's one reason that I was able to transition to offensive security so well. Is, I mean, I'm not an expert by any means. I mean, I hope that's one thing that my videos show, is that like I'm always learning, and there's a lot that I don't know. But I had been a systems admin for so long, and I had done some web development for so long, that I knew why things were vulnerable. I knew the shortcuts that people would take. I knew the code behind the vulnerabilities. I knew why things would break. And so when a spell or an attack didn't work, I'd know, okay, well, I need to try this or I need to try that. And that's something that learning SQL, you will be so much better at SQL injection just knowing just a little bit of SQL. I mean, I'm not making anybody a DBA. I'm not a DBA. I can't teach database administration. Uh, those people know the ancient arts. Like those people are like aligning table boundaries with the disk telemetry so that they can eke out like a little bit more performance out of the database. Because back when I was doing systems administration, disks spun. We had like spinning disks. And so depending on where you placed the bits on the platter, you'd actually get more performance. And so that's the kind of stuff that DBAs like really go deep on. So we don't need to go really deep, but just understanding the commands that are being ran on the background makes you much better at SQL injection. So let's talk about substring for a second. So if we're going to use the T web app database, if you haven't been following along with the series, let me post this in chat real quick. If you haven't been following along in the series, then all of the lab materials can be found at the GitLab that I just sent into chat. So check chat. Also, any of the videos in the series has the link as well, and that has the SQL servers, the web applications, like everything is there. In fact, the script that I wrote to automate this Boolean inference that I'm about to show you is also in that repository. So all of the lab materials will be there, and you can try all this on your own. Yeah. So, I mean, that's the problem, right? Is that if you just learn how to break a thing in one environment and it works there, and then you're asked to do it in a different environment, there's no guarantees it'll work, and you'll just be lost on why it didn't work. So that's why in the SQL injection videos that I've done, and even now, rather than just diving right into attacking the web application, like we're dropping into the SQL database and the MySQL database, and we're going to actually run the SQL and see how it works and see what responses we get, and then we can apply it to the web app. One of the hardest things about, I think, SQL injection on web applications is that we have to fit our output into the output that's developed by the web developer. And if you don't know what it's looking like on the back end, on the database itself, it makes it a lot harder to put the information you want into the web application. So there was a CTF that I did earlier this year, I think. COVID all the time kind of blurs together, but there was a CTF that I did where the fields that were being displayed by the web app were only a certain number of characters long. And so if you didn't actually know not only about substring, but how substring works versus just using it to do this Boolean inference attack, you couldn't actually get the whole string you needed to complete the challenge. So knowing substring and knowing that substring isn't just like one character at a time, but you can actually grab chunks of a string, you just would never have been able to figure out the challenge. So like being able to replicate the attack on the back end and knowing what the output actually looks like for the database allows you to kind of shoehorn that output into whatever the hell the website's trying to do. So let's do let's do let's do a simple thing. So we'll do like select table name from information schema tables. And what this query does, and I'm logged in as root, so we're seeing like all of the databases. What this table does, actually, let's log in as the web app user to make things a little more apples to apples. So we'll do this, but we'll do is it web admin, and I think it's admin foo. Nope. Okay. These config files are in the repository, so that's just what I'm looking at real quick. Actually, let's I'll show you where to find those. So if we so here's the repository. If you clicked on that link, here's the repository, and all of the Docker images are inside Docker. And there's two. So the SQL primer, the second series, was literally just kind of working inside of SQL and learning the different like the different queries, some of the basic queries, not all of the queries, but some of the basic queries. The SQLi site is where the web application, the vulnerable web application in its database lives. So we'll just go into there. And we see that there's a Docker Compose, so we can check this out. And this is setting up the web application container and the database container. This is the root password for the SQL database, but we don't care about that. That's what I logged in with previously, but we want to see what the web app sees. So if we go into the DB directory, here's where the SQL files are, and we can cat the DB setup, so the initial setup script for SQL. And if we scroll up, it's admin foobar. Oh, I did admin foo. Okay, so admin foobar is the password for the web admin user. Also, if you saw the most recent video and you were like, hey, is this AWS key real? It was real. It's not valid anymore. It's not for a real user, so don't think I'm doing weird stuff. Let's try that again. So it's admin foobar. All right, here we go. So if we show, we'll use tweb app, though it doesn't really matter. And then we do that again. So we'll select table name from information schema tables, and we still have a lot of tables here, but not nearly as many as root can see. A lot of these are just, actually, if we just do table name and table schema, we can see what database these are from. So information schema is where most of these tables come from. Outside of that, there's just the three. There's the tweb app users directory and comments, and then this top secret one that we kind of pivoted into in the last video. So so this is kind of what we're looking at. The query that we're actually dealing with for the most part is this one. So what we do first when we first find SQL injection is we kind of need to map out what the database looks like. This will allow us to target the information we want to find, or at least discover the information we want to find. It's also, you can split up, and I do talk about this as two different steps in the video, but you can split up fingerprinting the database. In other words, figuring out, is it Postgres, is it MySQL, is it MS SQL, whatever, and the mapping of the database. But you can kind of do them at the same time by just trying to map the database. Each database has slightly different meta tables. So like information schema is like MySQL and Postgres. And then there's like MS SQL has like a different layout. I don't work with MS SQL very often, but it has a different meta layout. And then Oracle SQL has like a different layout. So you can combine these two just by trying to map the database itself. But that's what we're doing. We're mapping the database. So say we're in this position where if we were in basic, we could do a union where we go union select table name and table schema. And we need the table schema here, or we just need like a 1 if we want, but we're getting 2 pieces of information back from the database from this web app. So we need to request 2 pieces of information back. So we might as well just grab the table schema so we know what databases they're coming from information schema dot tables, and we do the semicolon dash dash space. Now it's really important to not forget the space because MySQL and MariaDB won't recognize dash dash as a comment unless there's a space immediately after it. What you can find is that what you can find is that if you're going through the history of your form submission, I have that turned off for this browser, but if you like hit enter and then you like double clicked it and looked at the history again, and you clicked on this statement again, it will sometimes, depending on the browser, drop that extra space. And so when you run it again, even though it just worked, you'll it won't work the second time, and you'll like, go mad trying to figure out why. But just remember, double check that space is there. It's very important for MySQL. So we hit enter and we see all of this information. We can see, okay, here's the table name, here's the database name, and we scroll down and we can see all the different tables, and we see, okay, there's a comments, there's a directory and users, top secret, etc. inside of these databases. If we don't have union, okay, if we don't have union, so we try and do that same attack here, where we go union select, table name, and table schema from information schema dot tables space. Then we get this hacking attempt union clause detected, because it's telling us. Not all websites will tell you this, by the way. This is for demonstration purposes. So it's telling us that union is filtered. So we can't use union. If we go back to our SQL here, there's a statement or a function called substring where we don't have to use a union select. We can use a Boolean statement using and to try and infer two pieces of information at once. So let's rebuild what this query probably looks like. So we know that if we put in like Alex, we know that we're getting the first name and the email address back. So this query probably looks like select fname and email from directory. We know that the table is called directory, but we can probably guess. The really, when you're reconstructing the query in your head or in your test environment, getting the actual like names here aren't as important, because we're just using this for prototype. Where fname equals, this is where our input goes. So this is what's really important. All of this is just kind of guesswork to recreate this in our prototype. But so what we entered was, we did single quote to break or to close this input, and we said union select from, or union select username password from users, or no, we're doing something else. So we'll say table name from information schema dot tables. Okay, and we do the semicolon dash dash because really the query looks like that. So we're commenting this out. It doesn't matter as much. I like to include the full comment character and everything so that I can just copy from here and then paste in. If you don't put the full comment characters in there and you do a copy and paste, like you might, especially if you're doing something like the OSCP, or you're doing, some certification where, you're probably not sleeping very well. You probably haven't eaten very well for many hours. You're over caffeinated and under braining. I like to just keep everything the same as possible. So like when I'm copying and pasting around, my brain's not trying to go, oh, why didn't this work here, but it worked there. So just doing, so we'll just do the comment and everything. So if we hit enter, we get the same kind of output. Oops. Oh yeah, wrong number of columns. See, and this is why you'll get an error when you try and do something like you do union select table name from information schema tables. You'll get an error there. And actually, more realistically, you have a website that behaves more like this, where it doesn't give you those errors. So it'll just tell you like 0 results, even though you know, like, hey, like Alex should give us a result back, right? So if we do like Alex select from select table name, we'll get 0 results, and we're like, hey, why are we getting 0 results? Alex should work. This is why, is because we didn't match the number of columns. So we'll do table name, table schema, just to see this output. But if we don't have union select, what do we do? Well, what we can do is we can use the AND operator. So we're going to say blank. So give us first name and email address from the directory where blank exists. Or actually, we can't use blank. Sorry, we're doing AND. So where Alex exists. So this should return something, right? So this is a true statement. Anything that is blank is false, and anything that is not blank is true in most Boolean. So this is a true statement. So if we do AND 1 equals 1, we have a second true statement, right? So this is true and this is true. So we should get a result back. If we say 1 equals 2, we have a true statement and a false statement. And because the AND is here, it will only return if all of the ANDed statements are true. So we actually get 0 back. We can use this logic to actually start pulling out data from the database. And we do that with substring. So let's show what substring does real quick. So if we do substring and we put a select inside of here, and this is why substring is so powerful, because it allows us to add an additional select, even though we don't have union or stacked queries or anything like that. So we'll do a select table name from information schema .tables. And we'll do a limit of 1. Okay, so we only want 1 result back, and we'll also do an offset of 0. And these are we covered limit in the second video where we go over basics of SQL. So we should know what limit does. It just limits the number of results we get back. So a limit of 1 just gives us the first result. Limit of 2 gives us the first 2 results, etc. We haven't covered offset. What offset does is in a limit, it will tell you where to start that limit from. So offset of 0 means give me the very first one. If you say limit 1, offset 1, it'll say skip the first one, give me the second one, but only the second one. So we only want the first table. This will become very important in a couple minutes. So if we just do, let's see. So then we, so that's the select statement. Okay, so if we just ran this, let's just run this first. Stop with the highlighting. There we go. So if we run the select statement, we just get the first one. And if we do an offset of 1, then we get the second table, offset of 2, third table, fourth table, fifth table, etc. Okay, so that's what that is. If we do substring, also substir works. It's just an alias. It's literally the same function. The next thing we need to do for a substring is that we give it the starting character of the substring. Unlike if you're familiar with like scripting languages or other programming languages, when you do like a slice is what it's called generally, where if you want the first character, you want the 0th index. That's not the way SQL works. It's a little confusing. So we want the first character. So we put the 1 there. And then we say how many characters we want. Okay. And we're going to say 1. You can put like a whole range of them in there. And in fact, that CTF challenge that I was talking about earlier, where it only put like a little bit of information in there, what we ended up doing is like, if it had 8 characters available to it, in the first query, we'd say, okay, we want characters 1 through 7. And then the next one, we'd want characters 7 through 14. And then the next query, we'd want characters like 15 through 22 or whatever. And that's how we got the information that we needed. We constructed the whole hash that way. But for what's called Boolean Inference, we only want the first character and we only want 1 character at a time. Oh, right. Okay, so substring itself needs to be a select. Hold on. I almost never do substring like by itself. So you have an error. Oh, it corresponds to there. That's nice. Okay, let's. I have a syntax error. See, I told you I'm not an expert. Offset 1. And it doesn't. SQL Server substring function. Oh, wait. I'm just like Googling this right now. Select substring. Oh. Okay. Yeah. Sorry. There's multiple parentheses going on here that I forgot. Okay. So the syntax for this, I'll break down the syntax a little bit. So actually, let's start this example over a little bit. So we'll use tweb app, even though we're not using it right now. Okay, so if we select the string of MySQL rocks, if we select substring of MySQL rocks, and we just want the first character and one character, we get back M. If we do the second character, we get back Y. If we do the third character, we get back S, and so on, right? And if we do, like, we want the first character through the third character, we get the first character through the third character. Okay, that is how substring works by itself. Okay, so if we want to use this with a query, we can actually use a query inside of substring, and we need to surround it in parentheses so it knows that that query is all one thing. So now if we do a select table name from information schema, information schema tables, and we want the limit 1, offset 1, or offset 0. And then so if we do this, we get A, because all plugins is the first table. And if we say we want the second character, we get L. Third character, we get L, because all fourth character is an underscore, etc. So, so this is a kind of just like a naked substring. So we're hold on, there's somebody in the chat. So when evaluated, you get select plus substring. I was evaluated, or I was confused when you were doing select plus substring, which contains another select. Yeah. So it's the select. When in a database, you're always performing a query, and select is the query that returns data back to you. So when we're trying to get data back, we always have to do a select no matter what. What substring does is it takes a string, any string in the first place, and then gives you the substring of this character, starting at this character, this many characters. So if we just do MySQL, we get, M, Y, S, Q, and then L is 1 through 5 characters. The reason we're going to use substring specifically in this attack is because it allows us to run another select as the target string to substring. So we can, inside these parentheses, we can actually run a second query. If any other query would allow us to do this, we wouldn't have to do the one character at a time thing. But since it's substring that it's allowing us to do this, we have to get our characters like kind of one character at a time, or however many characters at a time. So substring is special because it allows us to run a nested query. So when we do, so when we do this second query inside, so substring, or sorry, not substring, select table name from information schema tables, and we want the limit of 1 and offset of 0. This entire query needs to be inside of these parentheses. We get A. And if we just showed like the whole thing, we could get the whole thing. So the inference comes in when we combine this with the other query. So if we show the other query again, we do a select fname email from directory where fname equals like this. That's what the query looks like. Since we can't do a union select, we have to combine these two statements somehow. So we're going to close this off. Then we're going to do an and. Actually, how do I want to show this? What's going to be the clearest way to show this? So if we do like we did this, select fname from directory where fname equals, and then we do like Alex, we get a response of Alex. If we do an and 1 equals 1, we get that back. And if we do a 1 equals 2, we get nothing back. This is where we get the inference from. We can infer, because we know that Alex will return something by itself, we can set up a Boolean logic question on the second half after the and. And if we get the response of Alex, we know that the second statement is true. And if we get 0 response, then we know the second statement, the second half of the Boolean logic is false. So what we can do is, and this is the part that you haven't seen yet. So we know how this select substring works and everything. But what we do is we add this and substring select table name, and we need something else because we need two, or no, we don't. Select table name from information schema dot tables limit 1 offset 0, and we want 1 and 1. And here's where the magic happens. If we do equals A, so let's break down what this looks like, and then we'll talk about why this works. So what we're going to do is we're going to select the first name from the directory where fname equals Alex. So once we get, actually, let me do this. So once we get here, this is what's given to us by the web application. Everything after that is what we've typed until we get to here, and that's also the web application. So we type in Alex and then single quote to make this part of the query true and to return Alex. Then we add an and, just like we did up here, to add some sort of question, some sort of Boolean question. We use substring to grab the first table name with an offset of 0, and we just want the first character, 1 character at a time. If that character equals A, then this half of the and statement is true. Okay? And since both the second half and the first half of the and statement are true, then it will come back with a response. So if we hit enter, we get a response. Now, if we did this with something that wasn't true, if we did like B instead, it would come back with 0. Are you starting to see the inference now? Are you starting to see how we can start? We go, okay, well, we know that the first character of the table is A. And generally, if you're doing this manually, you'll want to bring up like a notepad or something so that you can keep track of, what characters where. In the video, we're starting to come up on time. I want to stop around 10 because there's another live stream by somebody else that's starting at 10 and I don't want to overlap. But when the video goes up later today, I'll show you how to automate this process. But what we can start doing is we know that the first character is A. So we move on to the second character. Okay, so we change this to say second character, and then we do the same thing. Is the second character A? No. Is it B? No. Is it C? No. And if we go all the way through, we get to L, and L is the second character. Okay, and then we start the third character, and we say, okay, is the third character A? No. Is the third character B? No. And we go all the way through to the L, and we say, okay, the third character is L. Okay. So you can do this manually. One thing that you may be noticing is that the table, the first table that we have access to isn't lowercase a, lowercase l. It's actually uppercase A, uppercase L. This will match case insensitively unless we do, and this is super important because you can't actually, like, if you were to do like select table name from information schema dot tables where table name equals, like if we did all plugins, all lowercase. Oh, it is case sensitive, insensitive. Okay. That won't always be the case. It's better to know whether it's uppercase or lowercase. So what you can do with this is you add a binary in front of substring. So if you run binary and you pull the first character again and you set it to A, it'll come back empty. If you put capital A, it'll come back. So you know that it's capital A, not lowercase a. Looked up some SQL injection technique tutorial and never really understood why the Boolean logic matters until I saw this example. Yeah, so like this is one of the most complex SQL things that you can wrap your head around. There are other techniques that are also considered advanced, like binary, blind SQL injection. People call this blind, but it's not actually blind because if we did this inside, just take this and copy it, and we put this into here and submit. That's not blind. We get response back. What blind SQL injection means is that we don't get any response back. We don't get any like display of anything. So what blind means is like you could go, we can add another and do like a sleep 5. And so it'll take 5 seconds to come back instead of coming back immediately. So you can infer that the first two parts of this and statement were true because it slept 5. If they weren't true, if we put like B in here, it would come back immediately. So you use non-display techniques to infer whether or not your query was true. That's what blind SQL injection is. So like, even though blind, I think like blind SQL injection is harder, I don't think it's more complex. I think this like Boolean inference is like the most complex thing to really kind of wrap your head around. What's cool about this is that you don't have to iterate character through character. And so this is kind of important. If you're doing it manually, if you're automating it or whatever, you don't have to do it manually because you don't have to do equals. You can do less than. So if you're doing this just like A through Z and you don't care about case sensitivity, then you'd probably start with M because M's the middle of the alphabet. But when you're doing case sensitivity and you're dealing with more than just A through Z, you're dealing with underscores and dollar signs and periods and all kinds of stuff in table names. The way that actually works is it works on the ASCII table, and it uses what's called the ordinal number. And if you look at the script, let me just pull it up real quick. Look at the script that's in the repository. That's gross. You can see that. You can see here that I'm creating the ordinal range of characters. It's actually 32 through 123. Python's weird, so you have to do one more at the top of the range. But what these translate to is like ordinal, like 32, I think, is a space. And then 33 is like exclamation point or something. And then you get up to like the 40s or 50s, and that's where you start getting the capital letters, like capital A through capital Z. And then there's a few special characters in the like 60s range. You get 0 through 9 up there. And then you start getting into the 70s, and that's where, or 60s or 70s, I forget. Must be the 70s, where the capital letters are, or the lowercase letters are, and things like that. So if you think about alphabetical order being A through Z, but then you remember that capital letters are before, if you remember that numbers are before lowercase and capital letters are before numbers, then your less than, greater than kind of makes a little more sense, and you don't necessarily have to memorize the ordinal number. But so what we'll do instead of starting at M is we'll do like a less than A. And when we do that, we get back Alex. If we were to do a greater than A, we wouldn't get anything back. So we can start towards the middle of the thing, and we can say, okay, well, is it less than A? It is less than A. Okay, well, is it less than 0? It's not less than 0. So I guess 0 is above capitals. So we say, is it less than capital M? It is less than capital M. Is it less than capital G? It is less than capital G. And we can kind of like split the alphabet in half and half and half and half. And that'll drastically reduce the number of guesses you need to make to actually zero in on which character you're hunting for. But if you're automating it and it's local and you're not sending stuff over the wire and you're not sending stuff like through WAFs that's like detecting this stuff, you can just say, is it equal to A? Is it equal to B? Is it equal to C? So on. You're talking probably like, on average, you're probably talking like 50 to 60 more requests per character. Doing it, is it equal to A? Is it equal to B? Is it equal to C? Than if you were to do like less than A, less than M, kind of stuff. I believe, obviously, it's a lot faster if you're trying to get like millions of returns back. So once you find all the table names, then you need to find all the column names, and then you need to find all of the rows, right? So if you're talking like millions of returns, then 50 or 60 extra requests per character is like orders of magnitude more, right? So you can speed it up if you're doing like big dumping of databases. Also, if you're doing blind binary inference or Boolean inference, you can add a sleep here. And usually, like, you're going to end up sleeping, maybe not 5 seconds, but like 3 seconds but that's probably the lowest end of where you can accurately determine whether it's sleeping or if it's just lag, like the variance of the web page loading. So, if you add 3 seconds to every single correct answer, you're going to be adding a shit ton of extra time. So that's another reason you may want to like make the number of guesses more efficient. So with the excuse me, with the video coming out later today, I'm going to deep dive the actual script that I wrote. So basically what I'll do is I'll recap the stuff I just went over, just like a couple minutes, and then I'll go over the script that I wrote. Now the script isn't meant to be good Python, and it's not meant to be efficient SQL injection. It's supposed to be illustrative, so it kind of walks you through what each step is happening. Let's see what else, just to kind of automate this. Now, some people are like, well, what about SQL Map? Well, we'll go into SQL Map in a couple videos because I think it's important to understand what SQL Map is doing on the back end. Doing Boolean inference with SQL Map is possible. It's absolutely possible. It's actually the way I mostly do Boolean inference. But there's some weirdness to it that if you don't understand how Boolean inference is working, you may not be able to get SQL Map to do it correctly. And that's not a fault of SQL Map. It's just SQL Map will only do what you tell it to do, and it's only so smart to guess what you're trying to get it to do. So, so it's really important to understand this part, especially if you don't understand, like, if you don't understand that, like, this will work, right? It's like the longest 3 seconds of my life. But if you don't understand that this won't work, even though you accurately guessed that A is the first character of the first table, then you won't be able to get SQL Map to accurately do the binary injection or the Boolean injection. Okay, so it's 10 o'clock. I'm going to go ahead and close my stream up. This has been super fun. I'm looking forward to next month's stream. I'll figure out what that stream will be about closer to the time. If you are still looking for security content, I'm not going to be anywhere. There's going to be another stream on Twitch. If you go to, I will just paste this link into the chat here. I think that'll work. Yeah. So just head over there. They're going to be doing Backdoors and Breaches, which is a tabletop exercise card game to practice incident response. So thanks for hanging out. Thanks for the questions, and we'll do this again soon.